Now we'll go ahead and use the exponential smoothing method to forecast. This is found in section 6.3, and we can take a look at table 6.10. This is what we're going to try to recreate. So in exponential smoothing, we are given an alpha value. And we are told in this example that alpha equals 0.2. So I'm going to go ahead and put that down here in our worksheet. Please take a moment to set up your worksheet. But insert, just for a refresher, we'll go ahead and insert symbol, and we need alpha. So again, you want the Greek drop down. There it is. Insert. Close. Alpha equals 0.2. This basically helps us to understand a sense of the market direction. It'll be provided to you in our examples. So then to calculate our forecast, our first forecast here in week 2 is simply going to be the forecast or the time series value of the previous period. And as you can see, we're just using one period, so our K value is going to once again be 1. Now from then on out, we're going to weight the actual value with our alpha and add our previous forecast value weighted by 1 minus alpha. So how we do that is our forecast for week 3 is going to be equals our time series value from week 2 multiplied by our alpha again, that's going to be a relative cell or an absolute cell reference plus 1 minus alpha multiplied by our previous forecast. Make sure you have all your parentheses in there. Oh, and we could see that that was way too small. So we could find where my error was. There we go, that looks much better. Now we can just go ahead and carry this formula on down. From here on out, it's basically what we've been doing. So our forecast error is our time series value less our forecast, less our y hat. Carry that down, get the total at the bottom. Absolute value equals ABS, our previous error, or the error we just calculated. Again, carry the formula down, get the sum at the bottom. Squared forecast error, take your error and square it. And then percentage error is your error divided by your time series value. You want a percent, carry it down. And then finally, your absolute value of percentage error is simply the absolute value of the percentage error you just calculated. Go ahead and copy that down. So once again, that brings us down to our mean forecast error. We know that this now is the sum of our forecast errors divided by n minus k, and is still 12, but k is just 1 again, 0.993. Then our mean absolute error is the sum of our absolute errors divided by n minus k, 0.259 or 2.596. Then our mean squared error is the sum of our squared error divided by n minus k. And our mean absolute percentage error, or our MAPE, is the absolute percent error sum divided by n minus k, or 13.40%. So now we come to our week 13 forecast, and again we need to take into consideration our alpha. So here we have equals our previous forecast, or our previous actual value, our previous actual value multiplied by our alpha plus our previous forecast now multiplied by 1 minus alpha. And we can see that our week 13 forecast is 19.185 units. So again, this was an example using exponential smoothing.